Hello everyone. Now today we are going to see the next part of this Warnock algorithm. So in the last session we have covered what is the requirement and what can be the different cases of the Warnock algorithm. So today we are going to complete that. So let's see what is the Warnock algorithm is. So the Warnock algorithm is also called as the area subdivision algorithm because we are going to divide the area into the sub-area. Again the sub-area will get divided into the sub-area. So whatever the thing that we have seen before this Warnock's algorithm, that any algorithm regarding to this type, then there we have seen that in the Pentas algorithm we are following the procedures, okay, to remove the hidden surfaces. But now in this Warnock algorithm we are not going to find out any procedure over here to detect the hidden surfaces and to remove the hidden surfaces, but here we are going to directly display the final picture. So what idea we are going to use behind this is nothing but subdivision technique. So what is that subdivision technique? Whenever we are following this Warnock's algorithm, we are having the two-step strategy. In the steps 1, we are going to decide how many polygons or which polygons will overlap here in the given area of the screen. And in next step, we are going to find out over there that which polygons are visible in that given area. So these will be the two steps that we are going to follow. In the first step, we are going to decide that which polygons will be overlapping with the given area of the screen. And in the second part, we are going to find out the polygons are visible in that given area or not. So it may happen that polygon will be visible fully, it may happen that it will be visible partially, or it may happen that it will be not visible at all. So these are the two steps that we are going to follow. These are the two steps where we are going to work on these steps. So the Warnock algorithm will check whether the polygon is partially or fully visible in the given area. So if I am calling that area as a, so we will check in that area whether the polygon is visible or not. So in this we are saying that the Warnock's algorithm is working on the subdivision algorithm. So what is that subdivision? We are dividing the area into the sub-areas into the sub-areas likewise. So how we are going to do that? Let's see here. This area is divided into the 4 parts. I will calling it as a 1, 2, 3, 4, and after the division of this area into the sub-areas, again if we want to divide this area or a sub-area, how we are going to divide that and up to what we are going to divide this. So this we are going to check whether the polygon is visible in the given area or not. Until the visibility decision is made by us, up to that we can divide that area, or until, last thing is that until your screen area will becomes the pixel, up to that we can divide that area up to the pixel level also. So here we can see that if we are going to consider the area number 1, so this area we are going to consider. So again this area can be subdivided here like 1, 2, 3, 4. So this is what the subdivision algorithm. So what happened? First of all, in the whole area we are going to check whether the polygon is visible. Then in subdivision, in each area we are going to check whether the polygon is visible. Again in each sub area we are going to check whether the polygon is visible or not. So we can do this process until the screen area will becomes the pixel. Now moving forward, we are having the different categories of polygon which are based on the screen area. Okay, so 4 kind of things we can have there, 4 kind of cases we can have over there while we are considering the screen and the polygon. So what are the 4 cases? Let's see. The surrounding polygon, intersecting polygon, content polygon, and the disjoint polygon. So these are the 4 categories that we can have. Let's see, let's revise what are that. So surrounding polygon is nothing but here the area is surrounded by the polygon. This is called as a surrounding polygon. Here the polygon is completely covers the given screen area. So this is what the another example where area is surrounded by the polygon. This is called as a surrounding polygon. Second one is intersecting polygon. Intersecting polygon means when a polygon and the screen area intersect with each other. Means we can say that the polygon is partially inside of that area and partially outside of that area. Such a polygon and this area we can say as an intersecting polygon. So this is what the another example of intersecting polygon. Then third category is content polygon. Content polygon means in that the polygon will completely lie inside of the given area, that is called as a content polygon. So you can see here the completely visible inside of the screen area. So this is what a content polygon. Then last one is called as a disjoint polygon. So what it mean by disjoint polygon means the polygon and the area, they are totally different at a different place. They are completely disconnected with each other. So here we can see that whenever the polygon is light completely outside of the given screen area, that is called as a disjoint polygon. Okay, so this is what the 4 different categories we are having, and whenever we are going through this Warnock's algorithm, we are just working on the PVPL. So what is this PVPL? Here we are making one list. Its name is PVPL. Full form is potentially visible polygon list. In this, the polygon in a separate polygon list we can have over here, which is called as a PVPL. Okay, so if the polygon of the category 1, that is 4 category we have seen, the first category is surrounding polygon, then the whole area of the screen will get the color of surrounding polygon. Means this here it is an example of surrounding polygon. The area is surrounded by the polygon. So if such a condition occurs, then area will be colored with the color of surrounding polygon. So you can see here the area will be colored with the surrounding polygon. If we are having the category number 2, that is the intersecting polygon. So in that intersecting polygon, we are going to use, or we need a clipping algorithm to convert the category 2 into the category 3 and 4. So how we are going to convert the category 2 into 3 and 4? This is what the example of intersecting polygon. If we want to use the clipping algorithm, then we need to convert this into the 2 different format, that is the category 3 and the category 4. So what is the category 3? Content polygon. What is the category 4? That is disjoint polygon. So we are going to do the same thing, that intersecting polygon is converted into this category. This is called as a content polygon, and one more category that is called as a disjoint polygon. This one more category is called as a disjoint polygon here, right? So by clipping, first we have done the interior clipping, then we have done the exterior clipping, and according to that we are getting the content polygon and we are getting the disjoint polygon. So now for this intersecting polygon, we are going to work on the content and the disjoint polygon. What about the case number 3? If the category is like 3, that is content polygon, the polygon is totally lies inside of your screen, then here we are going to subdivide that area into the 4 sub areas, and again we'll apply the same logic. Again we are going to divide that area into the sub area likewise. So there is no point in applying the subdivision algorithm for case number 1 and the case number 4. There is no need to do that. So in this way we are going to work over here in this Warnock's algorithm with the 4 different categories of your polygons with your screen. Now if there are 2 polygons, then the polygon is not visible if it is in the back of the surrounding polygon. If we are considering the 2 polygon, and if we are looking from some point of view, then it may happen that the one polygon is surrounded by another, and so we cannot see the polygon, one of its polygon we cannot see. So if there are 2 polygons, if we are assuming P1 and P2, and the P2 is surround to the P1, the P2 surrounds P1, then it means that the P1 should not be displayed, that is P1 should be removed from our PVPL list. What it is saying that if the P2 surrounds P1, here you can see that the polygon P1 is completely surrounded by the polygon P2. So what we need to do? So we should not display P1 because it is surrounded by P2, and in that case we are going to remove our P1 from the PVPL list. Okay, so PVPL could be the list of smaller z coordinates of the polygon which are within the area, that is its z min we are going to check. So every polygon will have its value as a Z max and Z min. So according to the Z min, we are going to maintain our PBPL list, and Z max will be the maximum Z value of that surrounding polygon. ZS max, ZS, Z value of surrounding polygon, that is going to be a maximum Z value. So this information we are going to store into the PBPL according to the Z min and Z max. So here you can see easily that Z max of P1, two polygons we are having here, P1 and P2. So the Z max value of P1 is less than the Z min value of P2. How? Because this P2 is lying on the positive Z axis, whereas this P1 is lying on to the negative Z axis. So that's why this Z min of P2 is greater than the Z max of P1. It means Z max of P1 is less than to that Z min of P2, right? So the polygon in that case, if the Z max is smaller, so we can say that the P1 is hidden, and here the polygon P2 is surrounding polygon. So P1 is surrounded by P2, so we should not display this P1, but we are going to display this P2 because P1 is hidden. So we can say that the Z max of P1 is less than of Z min of P2, then P1 is hidden. The P1 is hidden, only we can see the P2. Okay. In fact, all other polygons after P1, means whatever the value we are getting after this P1, that all will be the smaller than the Z max of P1. If any value of the polygon which is smaller than Z max of P1 on that list will be hidden by the P2. So if we are saying that there are number of polygons behind this P1, okay, and their Z max is less than this Z max of P1, and in that case we can say that all the polygons that we are having will be hidden by this main polygon P2, okay, because its values are larger than that all other values of next polygon. So we are going to remove that all of the polygon from this PBPL list. So we can say here that the P2 is a surrounding to this P1. The P1 is surrounded by the polygon P2, and the Z max value of that P1 is less than to the Z min value of P2, and that's why P1 is hidden and we are not going to display that P1. So if there will be any kind of such a polygon is lying after this P1 also, and their Z max values are less than this Z max of P1, then we can also say there that the all polygons after this P1s are also hidden by this P2, okay, and we are going to remove such all polygons from our PBPL list. Then in fact, all other polygons after the P1 whose Z max value is smaller than this Z max of P1, means here the polygons are lines. So in that list, if we are saying that all the polygons that are having its Z max value is less than the Z max of P1, then that all polygons are hidden by P2, and we are going to remove that all polygons from there, okay. So in the another case, if we are saying that the polygon P1 is completely inside the polygon of P2. Now case is reverse. You can see here in the first thing the P2 is hiding to P1. Now P1 is completely inside of that P2. That is content category we can have. Means we can see the P1 and also we can see some portion of P2 also, right? So this is what the reverse or exactly opposite category of that previous thing. So here P1 is completely inside of P2, so we can see the P1 and we can see the some portion of P2 also. So this is what the content category we can say. And in this content category, if P1 is in the completely inside of P2, if P1 is in completely inside of P2, then a condition will be, here we can see that condition, the Z min of P1 is greater than the Z max of P2. How it is greater? Because this Z min of P1 is lying on the positive Z axis and the Z max of P2 are lying on the negative Z axis. So that's why this Z min of P1 will be greater than this Z max of P2, and in that case we can say that the P1 is in front of P2. means P1 is more nearer to the viewer than this P2. So P1 is in front of P2. So in this case we have to display the polygon P1 and fill it with the color of polygon P1, and then we have to fill the remaining area by the color of polygon P2. So this is what the content category. So initially we can see this polygon P1. So we will color it with the color of polygon of P1. Okay, and then we need to give the color to the remaining area that we can see that by the color of polygon of P2. So that is called as a content category. This is called as a content category. So if we are saying that if we are looking at the content categories example, so yes, here you can see that content category. This is what the P1 and this is what the P2. So we can see the P1 is content into the P2. So initially what we have done, we have colored the P1 with the color of polygon, and whatever the remaining area that we can see, or whatever the remaining area that is surrounded by this polygon P2, that will be colored by the color of polygon P2. So this is what the first polygon and this is what the next polygon. The part of the P2 polygon, some part of that P2 polygon is hidden due to this P1. So here in this part we have given the color of P1 because we can see the P1, we cannot see some part of the P2, and whatever the remaining surrounded part we can see, that is colored by the P2 polygon. So this is the thing of content polygon that we are saying. Now we are going to summarize this Warnock's algorithm. So what is the step number 1? Initialize the complete screen as an area. So we are going to initialize our screen area. Next we are going to create the PVPL with respect to the area, and we are going to sort that list according to the Zermin value. So we are going to prepare or build a PVPL list, and we are going to sort this list according to their Zermin values. Next we are going to categorize the polygon here. Okay, so which kind of category it is, whether it is surrounding polygon, whether it is disjoint, whether it is content. So according to that we are going to categorize it, and then we will remove the disjoint polygon because we are not working on that disjoint polygon. If they are disjoint, means we are not going to display that polygon, we are not going to include them into the PVPL list. We are discarding such polygons. Then in step number 5 we are going to perform the visibility test. So what is that visibility test? Let's see here. In the step number 5 we are going to find out the visibility test over there. So the first step in this step number 5 is that if all the polygons are a disjoint category, then set pixel color as a background color. If we are getting a disjoint category of the polygon, then there we are just going to apply the background color. No other thing is going to be do over here for the visibility test. Then the second step of this step number 5 is if the polygon is of the content category that we have seen in the previous slide, a content category polygon, then the color of the polygon and the remaining area as a background color. So we are going to give one color of polygon of P1, and then the remaining area will get a color of a background. Okay, so this is what the content category. Next is if we are getting a single polygon in the PVPL with the surrounding category, then set the whole area with the color of surrounding polygon. That is also we have seen in the starting of this PPTs that if the polygon is surrounded, right? If we are getting the surrounding polygon, then that screen is getting the color of surrounding polygon. That is also we are seen over here. If we want to see it again, so here we have seen that concept. Yeah, here. So this is what the surrounding example, and in that the area is getting the color of surrounding polygon. So this is what the example of this surrounding polygon. And last one is that if the area is a pixel, x comma y, then we have to find the z value of that polygon at the pixel x comma y, and when we are choosing the color of that polygon which has the smallest z value, then set the pixel to this color. Means after the subdivision, if we are getting the pixel, the area is going to be divided into the pixel, then at that pixel position we are going to find out its z value. Okay, so what is the smallest z value that we are getting from our PBPL list, and we are giving the color to that pixel according to the polygon which are having the smallest z value. So we can use that smallest z values polygon color to set the color of pixel. So whatever the color we are getting for the smallest z value of the polygon, that color we are setting for this pixel. So this is what the step number 5, which is nothing but the visibility test. In the visibility test, we are not going to consider the disjoint category, and in that case we are just use the background color. If it is content category, then P1 is colored with the color of polygon, and remaining part, that is will color with the background color. If it is surrounding category, then the screen area will be colored with the color of the surrounding polygon, and if we are talking about the pixel, then we are color them according to the smallest z values polygons color. Okay, and the last step 6 and 7 is, if none of the above case are true, means it is not a disjoint, it is not a surrounding, it is not a content polygon, then it will be a intersecting polygon, and if such a conditions occur, then we have to subdivide the area into the different areas, right? So again that sub area will be divided into the sub areas likewise. So if we reach to the stage where we can take some decision on visibility, whether it is visible or not, then we can stop this process, or we can say that our polygon and that sub areas are now the pixels. If we are dividing that area into the sub area until we are reaching to the pixel of that screen area, up till now we are doing this process, and after that we are going to stop this process. So these are the different steps that we can see for this Warnock's algorithm. So what kind of questions are asked here in the university question paper, that explain the Warnock's algorithm, why this algorithm is called as the area subdivision algorithm. So you need to explain it in detail, that how we are dividing the area into the 4 parts, again that sub area into the sub areas likewise. Okay, and we can show it diagrammatically also. And the next question is, write a short note on the Warnock algorithm. So same thing you have to repeat over here. You have to show the 4 different categories, that content, disjoint, surrounding, and the intersecting polygon, and according to that we have to write down the steps required for this Warnock's algorithm. So with this we are stopping today here. Thank you all of you. Thank you very much.